Hey, what's going on, AP Calc? My name's Andrew. I'm filling in for Mr. Kane today, and we're going to learn about lesson 4.3, L'Hopital's rule. So L'Hopital's rule basically states that if the limit is x approaches c of f of x over g of x is equal to 0 over 0, or infinity over infinity, then the limit as x approaches c of f of x over g of x can be rewritten as the limit as x approaches c of the derivative of f of x over the derivative of g of x. So this might sound confusing, but it's actually one of the more simple rules that you learn in AP Calc. Let's test a problem to see how this looks like. So example 1, we have limit as x approaches pi of x minus pi over sine x minus pi over x plus 1. So first step, unit 1 material, fill in everywhere you have an x, fill in the pi. I'm going to take a moment so you guys can do that. So filling in for x, you get pi minus pi over sine pi minus pi over pi plus 1. Taking trig rules and basic addition subtraction, you'll get that pi minus pi is 0. Pi minus pi is 0. Sine of pi is also going to be 0 due to trig rules. Negative pi over pi is going to be negative 1. And then plus 1 is going to be plus 1. So simplifying that, you get 0 minus 1 from that pi over pi plus 1. So, of course, negative 1 plus positive 1 is going to equal 0. So ultimately from there you get 0 over 0. Hopefully you all remember that any value where the denominator is 0 is going to be undefined. However, this limit itself is not undefined. Let's see why. So, based on L'Hopital's rule, because it evaluates to 0 over 0, you can take the derivative of the top and the bottom. So, how about you do that first? Derivative of top, derivative of bottom, and then we'll meet back. So, hopefully you guys got that derivative of x minus pi is going to be 1, and derivative of sine x minus pi over x plus 1 is going to be cosine x minus pi to x to the negative 2. So, plugging that back in based on L'Hopital's rule, it says that we can equate that limit, the top derivative of top over derivative of bottom, to f of x over g of x. So basically what that means is that this original function, original limit can be equated to 1 over cosine x minus pi x to the negative 2 as x approaches pi, as it does in the original function. So let's write that out. So you get limit is x approaches pi of 1 over cosine x minus pi x to the negative 2. Again, plugging in pi for x, you would get 1 over cosine pi minus pi times pi to the negative 2, which equates to 1 over negative 1 minus 1 over pi. So that's your final answer. You get 1 over negative 1 minus 1 over pi. So that's L'Hopital's rule. In the next video, you'll see a couple more complex problems that apply L'Hopital's rule. But essentially, what you need to remember is if it's 0 over 0, or if it's infinity over infinity, then you're taking derivative of top, taking derivative of bottom, and setting it equal to that limit of the original function. Awesome. Thank you.